Yeah. Oil droplets having a diameter of 20 microns are to be settled from air with a density of 1.137 kilograms per cubic meter and viscosity of 1.9 times 10 to the negative 5 Pascal second. Okay? So, meanwhile, the density of the oil is 900 kilograms per cubic meter. The droplet will be assumed to be a rigid sphere. Letter A, determine the drag coefficient for all the oil droplets as a function of the terminal velocity. And then next, calculate the terminal velocity of the droplets if the Reynolds number is 0.012. Okay, so let's write the given. You are given the diameter, so oil droplet. The diameter of the particle is 20 microns. And then the density of the fluid is 1.137 kilogram per cubic meter. The density of the particle is 900 kilogram per cubic meter. And that the viscosity is 1.9 10 to the negative 5 Pascal second. So what's being required? CD as a function of time, a function of the terminal velocity. And then letter B, terminal velocity of the droplet is okay. UT when the Reynolds number is 0.012. Okay. So with that, guys, let's go again to the formula. As a function of UT, we can see that the formula for UT, remember, 4/3 G dP over CD rho, and then the whole thing is raised to 1/2. So I can factor out CD to be 4/3 G dP rho P minus rho all over UT squared times density, right? So let's plug in everything. What is CD, guys? 4/3 9.81 point 20 microns. So that's 20 negative 6. And then density 900 1.137 all over UT squared. So we don't know UT, but we know this. It's 1.137. What will this be, guys? What is CD? So here, what you will get is 0.2068 over UT squared. Therefore, we can say that this is the letter A. For letter B, let's solve it. When Reynolds number is 0.12, so what can we deduce from here? You're already given the Reynolds number as 0.12. What can we deduce, guys? Yes, this is laminar region. So, Stokes' law applies. So if it's Stokes' law, let's go back to the formulas. So UT would take this form. Actually, it's the first equation. This one, not that number one. So let's write that. Ut is g dp squared rho of particle minus rho of the fluid over 18 mu. Can you please help me solve this one? 9.81, 20 times 10 to the negative 6 squared, 900 minus 1.137 all over 18, 1.9 times 10 to the negative 5. What is the answer? So 0.0103 meters per second. So this is your letter B. This is your letter A. Okay? So I hope it's quite clear in solving for this one. This is actually one of the easiest topics. It's very straightforward.